You guys have been describing functions for the last 3 months. Describing a function is literally telling me what the function does, giving me the equation. So let's look at this first one here. It says complete the table, plot, and determine whether proportional, non-proportional, or nonlinear. Remember, if it's nonlinear, it can't be proportional or non-proportional, can it? Now, let's start with this. Look at this format. What equation format is this?
Y equals mx plus b.
So, right away, can you tell me whether this is proportional, non-proportional, or nonlinear?
Proportional.
Does it go through the origin? Why?
Because there's y equals mx.
It's non-proportional. We can say that right off the bat without doing any work at all. Proportional. So, let's look at our input and output. Remember, input is what we put into the equation. It's always the x. So here it says the input is x. I always like to start with 0 because it gives me the y-intercept, right? So if the input is 0, what is 0 plus 5?
5.
So the output is
Y.
5. That's y, right? So what's my coordinates?
0, 5.
0, comma 5. Let's start with 2. Okay? And I can pick anything I want. When it tells me like this, I can pick any numbers I want. But be careful that you don't exceed your graph or life gets harder. So what is 2 plus 5?
7.
So the output is 7. And the xy is 2, 7. What number do you want to use now?
5.
6.
If you use something too big, you're going to exceed your graph.
3.
3. We'll go with the 3. So if x is 3, what's 3 plus 5?
8.
So my output is 8. So my coordinates are 3, comma 8. Whoops. And then I graph them. So 0, xy first, 0, comma 5. There's my y-intercept, right? 2, comma 7. 3, comma 8.
It's still a line. It's linear.
It is linear. Why did we know it was going to be linear?
Because it's right by each other.
Well, can it be non-proportional and be non-linear?
Yes.
No.
No, it can't.
If it's proportional and non-proportional, it must be linear. That's the requirement.
Whoa.
What's wrong?
Come on, draw.
Okay. Control the conversation over there.
Here?
There's somebody over there having a conversation. Okay. So, that one makes pretty much sense, right?
Yeah.
Let's look at number 2.
Hey, that's mine.
It says complete the table, plot, and determine whether proportional, non-proportional, or nonlinear. Well, this one's a little different, isn't it?
Yes.
So, remember to keep the numbers low or it gets messy. Let's start with 0. I always start with 0 because it's easy. What is 0 squared?
0.
Oh, and this should have been minus 2 up here. That top one should be minus 2. So 0 minus 2 is what? Negative 2. So my output is negative 2. Which means my coordinates are
0, negative 2.
0, negative 2.
No, that's your x and y, not your output.
So let's do an input of 1.
Oh, I get 2.
What's 1 squared?
1.
Minus 2?
Negative 1.
Negative 1. So my output is negative 1. My total coordinates are 1, comma,
1,
negative 1.
Negative 1.
Let's go 2. What's 2 squared?
4.
What's 4 minus 2?
2.
So my output is 2. So my 2, comma 2. Now let's plot them. So I got 0, comma, negative 2. Way down here. 1, comma, negative 1. 2, comma, 2. Is that a straight line?
Yes.
You can't. What that is actually is a parabola. It's half a parabola, but if we finished it, it would actually end up being both sides. Whoops, that's a terrible side there. It actually end up as a parabola off both sides. Is it linear? So it's just nonlinear. It is, but we haven't gone there. It's a good word. It's just it's not there. It's nonlinear. Does that make sense? So what we're looking for.
I was about to get up and leave.
No, what we're looking for is we want to know, is it proportional, non-proportional? What kind of function is it? Is it linear or non-linear?
Non-linear.
That's as hard as today gets.
Oh, so you don't have to write this out?
You may have to write the equation if you just have the table.
That's what you get.
Okay? Any questions?
No, sir.
Yeah.